Python's had tremendous success. Why? How do we get here? What are some of the things that are potentially allowing this to happen in the future, and what are things holding it back? As a hint, array computing in Python's been a big reason. When I first started in Python, I got to know Guido pretty well and other leaders. Raymond, for example, is a good friend. And I learned a lot from them. But I also recognized that why did I, as a scientist, come to Python? What brought me to it? And then why have we kept using Python as scientists? So that when TensorFlow and PyTorch showed up to the scene, they were sort of forced to write Python. In fact, I remember when PyTorch came out and it was Lua-based. And all the people built it you see in Lua, and yet the demand for scientists and users of deep learning was Python. So they sort of were pushed into making Python interfaces. TensorFlow was the same way. So how did we get there? It was array computing that helped us get there. So I started using Python a long, long time ago. 1.4 was the version of Python. Any 1.4 users? There's probably a few. Come on, maybe a couple. 1.4 was released in 1996. A while ago at Anaconda, we kind of as a joke, but not really. It was kind of for fun, too, to show we could do it. We have a package manager called Conda, and we Conda installed Python 1.0. So you can now Conda install Python 1, just as easy as you can install Conda Python 2 or Python 3. You can manage your Python installations as well. So 1.4, I remember when 1.5.2 came out, and I was so glad. I was so happy because it was added all these important features. Fortunately, 2.0 came out, and actually some very important things happened in 2.0. In Python 2.0, there was a merger. Basically, pre-Python 2, all classes you built with Python syntax were instances of one basic type in Python called the class type. So you had int type, you had float type, you had class type. And every class you built in Python was an instance of that type. Python 2, and the introduction of meta types is how it was done, basically. There was the ability in there in Python 1, but in Python 2, Guido managed to connect these two, so you could then inherit from ints and floats. You could basically have classes, new style classes they were called, that could be real types, real extensions to the language. Python 2 was a very important change. One of the challenges we have in the array community is actually Numeric, NumPy, built on Numeric, is still a Python 1 style array object. It really hasn't learned the lessons of Python 2. Part of this is because finding people who are both computer scientists and like figuring out type systems and type theories, and also know enough science or linear algebra to recognize that you're not done when you make a one-dimensional array, that a two-dimensional array actually matters, a multi-dimensional array actually matters, and how you do it matters. That because that set of people is so small, typically languages have ignored it. And that's one of the reasons Python succeeded, is because there's enough people that didn't ignore it. There's still a challenge because there's still a lot of people in Python land who don't really get why arrays are different. Why aren't they they don't really get why complex numbers aren't just two floats. They don't really understand why everything just doesn't fit into one category. But it doesn't. And understanding those details will help you understand why Python's popular for array computing and how to continue to make it popular for array computing. And we're all glad Python 3 happened. In fact, NumPy was written when I started the NumPy project 2005. I intentionally pushed it to the Python 3. I talked to Guido about it, talked to all the Python core developers about it, and sold it as a Python 3 feature, thinking that Python 3 would be out basically by 2007 or 2008. First version of Python 3 took a little longer, 2009. And for me, the first version of Python 3 that I would really be excited using was Python 3.5, maybe 3.4. 3.5, but basically 3.5 added so many good things to the language that it became something everybody wants to migrate to. And the entire NumPy SciPy stack got on board by roughly the 2014 timeframe. Everybody had a plan to migrate. And by 2015, 2016, every major package was Python 3. And now everybody's completely moving to Python 3 and giving up support for Python 2. So how many Python 2 users do we have in the room that are willing to admit that still? No, it's fine. Python 2 will be supported for a long time. I still am a Python 2 user as well. But Python 3 is definitely the future. It's definitely got enough features now and enough support, so it's going to be the future, and all the packages will support it. Now, Python 2 will be around for another 5, 10 years, but more and more will be supported just by companies. And the open source community, by next year, is going to be strictly on Python 3. All of our Quantsite projects are Python 3. All the new future projects are Python 3 only. So NumPy didn't just spit out of a box. NumPy was there because very bright people. Jim Fulton's embarrassed when I point him out here, but he was one who I met in 1996 when I joined the Python community. He worked on a matrix.py object. So it was kind of a simple thing. He felt like it was a throwaway piece of code. Matrix.py, it defined a matrix in Python. And he put it on the internet and engaged with people in discussions about it. Because he engaged with people in those discussions, a community built up and said, hey, we should really define something here. And then there was also a graduate student named Jim Huguenin who had time to spend all his time working on something called Numeric. And over the course of about 6 to 7 months, he built something called Numeric.py. And Numeric was a C code with some really clever typecasting, some really clever for loops that did fast math on blocks of data. And that was Numeric Python. And that's what existed when I came to the language. If that hadn't existed, I probably never would have found Python. I'd probably still be using something else. So NumArray was the second one. I was a scientist at Mayo Clinic doing my MRI and ultrasound, things that I thought were fun. I came to use and supported Python in 1998 because, one, it was easy to understand the resulting code. It fit my brain, and I could think about my domain and not programming. Easy to connect to C and Fortran libraries. That connectivity is critical. That's why scientists use it. That's why it's so popular. Complex numbers built in. A lot of people ignored complex numbers. Java did, to their peril. Multidimensional arrays were supported by the syntax. Little things like colon, comma, colon in an index notation meant you could support multidimensional arrays from the beginning. There was an existing numeric Python. There are familiar examples about it. There's a community full of smart people. I can get things done. So NumPy was created to merge these array objects. Took a few years. Finally, the whole community unified and joined, and you ended up with this enormous community of people using Python and NumPy, kind of a common array object. It actually completely surpassed my expectations. I knew I wanted to kind of help unify the community, but there was such a latent demand for it that it just exploded once this was there. In the next several years, we've had phenomenal success over the past 10 years. This stack of tools has done things like help people find gravitational waves. It's helped the Higgs boson discovery. The black hole imaging project, which I just recently got to meet that team that found, the EHT imaging team that found the black hole. Fantastic project, fascinating project. It's one of the joys of my life to be able to talk to people, scientists who do this work, and realize they're using the set of tools that me and my closest 2,000 friends made.